All right, guys, so 6.2, once again, I'll break this up into two parts. So we're going to spend 2 days on this, and our topic is factoring. Our topic is factoring. So what is factoring? Factoring is unmultiplying. If I can have the freedom to invent words here. So, for instance, this is multiplication. If I have x minus 2 times x plus 2, and I use my little shortcut that we learned yesterday, and I get this, that's multiplication. Okay? Factoring is the opposite. Factoring is where you start with this and you break it up into what it was before it was multiplied. Okay. So that's what factoring is. These two things down here, when you're all done, these two things are being multiplied. These are called factors. So that these are factors. So if you start with a polynomial and you unmultiply it, you're engaging in the process of factoring. The result, each of those pieces are called factors. Okay. So why do we factor? Well, there's a lot of reasons we use factoring. It's a really important skill in mathematics. So you use it to solve equations. You use it to graph. You use it to simplify. And those are all really fundamental skills in algebra, doing all three of those things. So factoring is like a real important skill to know how to do. Once again, none of the stuff we're learning today is new to you, but it's important to review because I know factoring for sure. Even my kids that are like, valedictorians in calculus, they still like, I don't know how to factor. So we need to factor. We need to practice. So the first thing that you're always going to do is you're going to start by taking out a greatest common factor. Sorry. You always do that first. Take out a GCF if possible. I'm going to make like a little tree here to help us make decisions on how to factor. So our first example problem today is going to be just that, is practicing how to take out a GCF. But sometimes after you do that, you're still not done. You have more to do. And to factor it some more, it depends on how many terms are in your polynomial. So if you have 2 terms, it could be a difference of squares. Notice I'm saying it could be. And you guys may not remember what I mean by difference of squares, but if you have 2 terms, it could be a difference of squares, and we'll learn what we are going to review that today, what a difference of squares is. And that's another factoring strategy. So we have GCF is one factoring strategy. Another factoring strategy is the difference of squares. You always start by looking for a GCF. But after that, if it has 2 terms, maybe it's a difference of squares. It may not be, but it could be. The other part of this is if we have 3 or 4 terms, we're going to use the box method. If you've got 3 or 4 terms, then we're going to use the box method. After that, if possible, keep going. If necessary, keep going. I'll show you this chart again tomorrow. Today we're going to start off a little bit simpler. We're going to look at problems where they are just a GCF. Then we're going to look at problems that are just a difference of squares. And then we'll close out today looking at problems where you just use the box method. We'll spend 2 days on the box method because that one takes a little bit more time for students. But once we've got those 3 strategies down, then I'm going to give you a polynomial where you have to do various factoring strategies, and you have to factor a few times to get it completely done. So today, 1 strategy at a time. Tomorrow, putting it all together and doing a whole bunch of strategies at once, okay? But that's kind of how you go through doing factoring. So that being said, we're ready to go ahead and take a look at our first factoring strategy, which is the GCF method, okay? So let me bring up an example here. Actually, let me change slides. I didn't print notes today. Oh, but the one you're looking for might be in that basket, but I'll help you find it. Oh, right there by an eye, I think. But I'll let you know if it's different. But I think that's it. So let's call this example 1, and let's title it Factoring Method 1, the GCF method. GCF stands for greatest common factor. So go ahead and write down example 1, the directions there, the title, and then the problem. And then we'll do our first exercise. Thank you. Actually, you know what? Never mind. That's not it. That's from another class. I didn't hand out notes. It's just a video. All right. So here we go. How do you take out a greatest common factor? Well, it's kind of like the opposite of distribution. So let me just kind of give you a little heads up. Don't write this, but just watch for a second here. You know, if I had this and I distribute, then I'm multiplying into the parentheses, right? So 3x times x is 3x squared. 3x times negative 2 is minus 6x. Well, taking out a GCF is like the opposite. It's like asking, what can I take out? Or in other words, divide out, because we're doing the opposite. And if I divide it out, what would be left? So it's the opposite of distribution is what it is. So when you're doing this, the first thing you want to do is to see if you can divide out any common coefficients. Can we divide out a common coefficient? So taking a look at 12, 20, and 14, the coefficients. What's the biggest number that goes into all 3 of those? 2, right? So I could take out a 2. Now, here's another little note for you. If the first coefficient is negative, take out a negative also. If the first coefficient is negative, take out a negative also. So as you guys said, the biggest thing that goes into all 3 of those coefficients is a 2. But since my first number here is a negative, I'm going to take out a negative 2. Okay? So let's put some parentheses here. I'm going to put a negative 2. I'm going to leave a little space here because we're going to take out some more, but we're going to take out a negative 2. Now, if I divide negative 12 by negative 2, what would that give me? And if I divide positive 20 by negative 2, what would I get? Negative 10. I'm going to leave the x's out for now. We'll come back to that. And if I divide out a negative 2 into positive 14, what would that be? Okay. So the first thing you do is divide out whatever you can, the biggest thing, the greatest common factor. And as a little twist, if the front number is negative, take out the negative also. All right. Next. How many variables can you take out? How many variables can you take out? So notice, how many x's does this guy have? It's got 4. Now when I say how many x's does it have, I mean how many times is x being multiplied by itself? It's 4 times. So there's 4 x factors there. How many x factors are here? And this one has 2. Now I can only take out the greatest common factor. So what's the most that I could take out that they can all give? We can only take out 2. We can only take out 2. Yeah, this guy can give up 4, but that wouldn't be fair because he can't afford that. This guy only has 2. So basically, whichever one has the least, that's how many you're allowed to take out. So I can take out x squared. X squared. Now, I'm going to divide this by x squared now to find out how many x's are left. What's x to the 4th divided by x squared? It's x squared. Now, it's not because you're dividing the coefficients, it's because you are subtracting them. So in other words, whatever you take out, just subtract that number from that number. So 4 take away 2 is 2. So there's 2 x's left here. All right, so this guy had 3 x's, but I'm taking out 2 of them, so how many will be left? 1. This guy had 2 x's, and I took 2 x's out, therefore he no longer has x's left. All right, so there it is. So that's the GCF method. Can you divide out a common coefficient and make sure if it's the front one's negative, you take a negative out also. And then also how many variables can you take out. So that was an example, but we'll do a practice together for the next one. All right. So any questions before we move on? All right, so we'll do a guided practice here. So you don't need to write any new instructions, but just write down number 2. Okay, so the first question is, can we divide out any common coefficients here? What coefficient can I divide out? So think about it. I'll give you a few seconds, then I'll ask you. What coefficient can I divide out? And what do you think, Megan? I could take a 7 out because 7 goes into 21, and it also goes into 7. So if I divide out that 7, Josh Kramer, what will the coefficient be here now? And what will the coefficient be here? Yeah. All right. Next, we want to ask ourselves, can I take out, notice, by the way, I didn't take out a negative this time. And why not? The first number wasn't negative, so we don't need to do that. Okay? So I just took out a 7 this time. All right. Next, we want to take out some x's. So my question to you is, don't answer, I'll call on somebody, but how many x's can we take out? A few thoughts out there. I'm going to ask Danya what she thinks. Danya, what do you think? Okay, we can only take out 1. The reason why is because this guy can only afford to give up 1x, so that's all I'm allowed to take out. It has to be something they have in common. So if I take out an x, Let's see what's left on the inside. Elizabeth, how many x's will be left here? And then Timothy, how many x's will be left here? None. So I'm done. So that's the GCF method, okay? All right. So student practice now. Try this guy on your own. I didn't pick these huge numbers on purpose. It just turned out that way. But let's see how you do. See how you do. Take out your GCF. I always see these memes where they talk about how math problems the teacher gives you in class and then math problems on the test, and it's like the ones on the test are way worse. Belen, how many B's can we take out of there? We've got 5 B's because this guy has the least amount, so I'm allowed to take out 5. If I take 5 B's out of all these, the first one will have 3 left, the next one will have 2 left, and the last one won't have any B's. All right, next question. Jan, what's the biggest number that divides into 100, 40, and 90? 10. So if I divide 100 by 10, I get 10. If I divide 40 by 10, I get 4. And if I divide 90 by 10, I get negative 9. And that's it. That's our GCF method. So anytime you're factoring a polynomial, that's the first strategy you'll use, is always look for a GCF first. But once again, today, we're looking at one strategy at a time. So we're going to leave GCF now and move on to one of our other factoring strategies. The difference of squares. So we'll call this example 2, and we'll say factoring method number 2. It's called the difference of squares. It's called the difference of squares. We're not going to do a GCF this time. No. Matter of fact, you can look and see they don't really have a GCF. They don't have anything in common to take out. So we're going to not do the GCF on this one. We use a different method. Now, don't write this. I do want you to write the problem down. But what I'm about ready to write here, don't write it down. We did this yesterday, right? This was one of our shortcuts we learned. These are opposites, right? The conjugate pairs. So when you have that, you do first times first, last times last, and you're done, right? This is the opposite of that strategy. They call it a difference of squares because when you use this strategy, you end up getting a difference of 2 numbers that are perfect squares. By perfect square, it means like they have a square root. The square root of 49 is 7, because 7 times 7 made 49, right? And the square root of x squared is x, because x times x is x squared. So it's a difference of squares, right? So I should probably write this down. If we have a difference of squares, two perfect squares being subtracted, then it factors like this. You take the square root of this number, which is x, and you put it in 2 spots. You take the square root of that number, which is a, you put it in 2 spots. You make one a plus and you make one a minus. It's just the opposite of what we learned yesterday with that shortcut. Okay. So now, I'll wait a second, and then we'll do that sample problem there on the left. But you got to be careful. This might be a little something extra to add here. Be careful. Sums of squares don't factor. I'll explain that, but I'll let you guys write it first. Matter of fact, I'll do this problem first, and then I'll explain that. Don't let me forget. I might forget. It'll make more sense, though, if we do the problem first. Okay. So, does 1 have a nice square root, you guys? What is the square root of 1? It's 1. Does 4x squared have a nice square root? What is it? 2x, right? So, these are both squares, then they're both perfect squares, and it's a difference, right? So we have a difference of squares. So here's how this one works. The square root of 4x squared is 2x, and you put it in 2 spots. The square root of 1 is 1. You put it in 2 spots. One's a plus, one's a minus, and you're all done. Okay, that's the difference of squares method. It's unmultiplying it. All right, so now remember I said be careful, the sums of squares don't factor. I have that little note down there at the bottom. If you ever see this, you don't have to write this, but if you ever see this, you can't factor that. There's no way that would ever have come about from 2 binomials being multiplied together. This is kind of like a trick question, if you will. It just wouldn't happen. In case you guys are wondering why, well, remember the whole reason why the middle term went away when we did these yesterday was because these were opposites. And since those are opposites, you always get a minus here. Well, if you don't have a middle term, why is this a positive? Because they had to be opposites, so it should have been negative. So what that means is that's just not factorable. It didn't come from 2 binomials being multiplied together. All right, so let's do a guided practice, of course. So go ahead and write that down. All right. So we have a difference of 2 squares here. So we're going to write this. Nicole, what number will go here?
5.
You take the square root of that, it's 5, so you put a 5 here, and you put a 5 here. Nice job. Areli, what number goes here? Good. And also, since there's an x squared here, right, the square root of x squared is just x. So when you take the square root of this, you get 3x. So it's going to be 3x. And then one's a plus, one's a minus. And by the way, the order doesn't matter. If you put the minus first and the plus second, it doesn't matter because multiplication works the same either way. So there's that. Okay, so try that one on your own, and I'll ask you for the answer in just a sec. So Joshua Marquez, what did you get there? That's it. All right, any questions on that one for me, Lou? All right, so now we're going to go to our last strategy. The last strategy is the more tedious of them all, okay? So take some time. Be aware these ones take some time, some focus. I would encourage you to take some good notes. I'm going to write some steps to go with them too. Now, some of you guys may already know how to do this. Awesome. And some of you may not even use the strategy that I use. Awesome. Just make sure that you get it right. That's all that I care about. But we're going to go ahead and use the box method for this because it has 3 terms. So remember, we're talking about 3 methods for factoring today. GCF, difference of squares, and that's our last one. We're talking about the box method. The box method. All right? And you use the box method anytime there are 3 terms. Anytime there's 3 terms, or 4 terms, which we'll talk about next time. Anytime there's 3 terms. And out of all the factoring methods, this one's the most frustrating one because it doesn't always work out on your first try. You have to try it. If it doesn't work, you got to try something else. It's a guess and check method. And sometimes there's a lot of choices to go through. So here we go. Step one, once again, I would encourage you to write down these steps, is you're going to draw a box where you put the first term here, and you're going to put the last term here. Now remember, this might be helpful if you guys remember this. You don't have to write this, just pay attention though for a second. If I have x plus 3 times x minus 2, I would use the box method for this, right? Once again, don't write this, just watch. And I multiply these together, I multiply these together, I multiply these together, and I multiply these together. And my final answer will be x squared plus x minus 6. The plus x comes from combining these. But I want you guys to notice we're going to be working backwards. So we start with this, and I want to get here. So how do we do that? Well, notice your first term here goes here. Your last term was here. Okay? So the first term goes in the top left, last term goes in the bottom right. What we're going to do then is we're going to try to guess what these numbers on the outside are. We'll know that we're right if these two diagonal numbers here add up to make the middle. Okay? So that's our strategy that we're going to be going with today. So first term goes in the top left, last term goes in the bottom right. So let's do that. Step one. What am I going to put here? 6r to the second. And down here? 4. All right? So that's the first thing we're doing. Now, the second step is I'll just put F and L here. We're going to try to guess what these numbers are here. So what times what? What times what will give me 6r squared? I'm going to make this a little bit bigger. So what do you guys think? What makes 6r squared? What times what? 2r and 3r. Sure. Now, maybe you would choose to put the 3 on the top and the 2 on the side. We don't know. Doesn't really matter. Okay? But just so you guys know, they will always split the r's up evenly. So if there's 2 r's, if I split that up, there's going to be 1 r here and 1 r over here. They're not going to put all the r's on one side and some on the other. It just doesn't work that way. So we'll always split the r's up. But this is not the only way to get 6r squared. You could also do 1r squared times 6r. I'm sorry, 1r times 6r. That would also work. So that's why there's guessing and checking going on. All right, now what about 4? That's the next step. The next step is to figure out what two numbers would make the 4. So what times what? Yeah, we could do 2 and 2, or we can do 1 and 4. 2 and 2 or 1 and 4. All right, so which one would you guys like to try? 2 and 2 or 1 and 4? 2 and 2? Okay. So since they're the same number, we'll just put one there, one there. I'm running out of steps, so I'll put my steps here. Now, at this point, we're going to complete the box. We're going to complete the inside of the box there. So what would go here? 6r. And what would go here? 4r. We need to check our answer now. It's possible that it's not right. So how do you check your answer? The diagonal should add up to make the middle. I'll wait a second for you to finish writing that and then I'll explain. Okay, so the diagonal, this diagonal here, those two numbers should combine to make this. Does 6r and 4r, do those add up or subtract somehow to make negative 11? No. Guess what that means? Our guess was wrong. Okay, and that's why these are kind of frustrating, because you don't always get it on your first one. So now I'm going to give you guys some guessing tips. Ready? The first thing you want to do is switch the numbers, switch the location. Okay, switch the number location. Now, guys, if I switch this, what I mean by that is I would take these two numbers and swap them. But is that going to matter here? No, because they're both 2. So there's no point in that. But we could switch these ones. I still don't think that's going to matter, though. You're still going to get the same thing. But you should try that first. It's kind of like when you're in a relationship. You know, you have one bad day. You don't give up on them right away. You know, give them another chance. So I don't want to give up on 2 and 2 just yet. I want to try swapping them. Keep those numbers. But if that's no good, then we want to get rid of those numbers and we'll try a whole new set. So let's try another set of numbers. So if that fails, try another set. Try another pair of numbers. So what else makes 4? 4 and 1. We'll see if that works. No guarantees. Because right now I'm trying to get a different way to make 4, but it could be a different way of making 6. So let's try 4 and 1. Let's try filling in our box again. This is, now it's going to be 3r, and this is going to be 8r. Can 8 and 3 make 11? Yeah. Huh? If they're both negative, right? Because we want negative 11. Which means both of these need to be negative then. So, switch the numbers location if it doesn't work the first time. So just take the numbers you got and swap them. Try another pair if that doesn't work. Now I'll give you another hint, another useful hint. You guys will notice that, let me write the answer first and I'll give you the last hint. So the answer is 2r minus 1 and 3r minus 4. We're done. Now, I'm going to give you another hint here that I would encourage you guys to write down. Notice that I put the 4 down here, and I didn't put it here. Let me tell you why I did that, because I knew it wouldn't work, and here's how you can know it won't work also. The column here, in the row, they can't have a GCF. So if I put a 4 here, do these two numbers have anything in common that you could divide out? Yeah, there should not be a GCF in there. If there is, something's wrong. Matter of fact, I could have gotten this whole problem on my very first try just knowing that fact alone. Let me tell you why. Remember how we tried 2 in the beginning? Well, 2 and 2 goes like this. Is there a GCF? No good. What if I switch them? Well, it's the same. Do I still have a GCF? Don't even bother. So I move on to 4 and 1. Oh, I know 4 can't go there, so I would have jumped right to the answer because of that GCF trick. So don't put a number in the same column or row if it has a factor in common with that number that it's with. Okay, it shouldn't be there. It shouldn't be there. So no GCFs. That could save you a lot of guesses. That could save you a lot of guesses. Just knowing that they shouldn't have a greatest common factor. And like I said, for this problem, if you guys had known that, we could have gotten the answer like right away without any guesses. And I knew from the beginning those twos weren't going to work, but I wanted you guys to see those steps of what to do if it doesn't work. Because sometimes even if you don't have GCFs, you still have to mess with things. It's still not going to work out 100% of the time. All right, so a lot of steps here, guys. There's a lot of steps. First and last, find one pair that makes the first, find another pair that makes the last. Complete the inside of your box and make sure those diagonals add up to make the middle. Check your answer. After that, switch the number location, try another pair, make sure there's no GCFs the whole way, and we'll get there. It takes a little bit of time, a little bit of guessing. All right, once again, if you guys remember a strategy from last year and you can get the answer really fast, awesome. So hopefully you guys wrote down those steps because there's a lot. We're going to do another one here. Go ahead and write down this guy. I'm going to ask you guys to walk me through this here. So do the first step. Do the first step. I'll give you a second. All right, so Michael, what's the first step? So what do I put and where do I put it?
For r squared in the left, in the bottom right,
Great. Okay. Now this next step we're going to do together because I want us to be on the same page. But just think about what the next step is supposed to be, and I'll ask you. You think of a guess, but don't write it down on paper unless you want it. Unless you feel really confident with this and you don't want to wait for me, you can. But so Jordan, what do I do now? I want to find two numbers that multiply together to make 4r squared. So I'm going to ask. What would you guess? You did 4 and 1? Okay. So 4r and 1r. Now we're doing this as a team, unless you're working ahead of me. And we'll agree that we're going to go with that. Okay? Some of you guys might have thought, well, I would like to try 2r and 2r, but hey, we're going to go with 1 and 4 right now. All right. My other angel here. Other than this, what's the next step? So I want you guys to think about what those numbers for the other one would be. Kind of only have one option here. What do you think, Destiny? Yeah. So we know that one of the 7s has to be negative and one has to be positive. And by the way, I do the signs at the end. I didn't really state that explicitly last time I did this, but I'm just going to put 7 and 7 for now, but it's good to remember one of those does have to be negative. But I like to do it at the end because that way I can kind of like change things around if I want to. But yeah, 7 and 7. Now you could say 1 and 49, but just so you guys know, usually when the numbers are that extreme, not very likely. Not very likely. So 7 and 7 is a good guess. So let's ask Austin, what's next? Complete the inside. Good. So I'll ask Isaiah, what's going to go here? 28. Ivan, what's going to go here? And R. Because 7 times 1R is 7R. Okay, so now, Esteban, what do I do now? We want to check our answer. How do we do that? Well, we look at the diagonals and we ask ourselves, is there any way these two numbers can be combined to give me this? What do you guys think? Yes or no? Yeah, that's cool. That's happy. I don't have to guess again, probably. It'll work if one of them is negative, right? Which one, this is why I like to wait to do the signs until the end. Which one should be the negative to give me a positive 21? The bottom left one, right? So if that's negative, that means this 7 must be the negative one. Okay? And there you have it. We got our answer on our first guess. So that's kind of cool. It doesn't always work out that way, but we did. So let's just say it didn't work. Let's just say it didn't work. Max, what would be the first thing I would try if it didn't work? Just swap where they're located. Don't change the numbers, just change where they're located, right? Let's say you swapped those numbers and that didn't work, Zakira. What would you do then? What if just switching where the numbers are at doesn't work? Try a new pair of numbers. I mean, I don't think I'd want to try 49 and 1. It's very unlikely that work. But maybe I'd come back here to this guy and try 2R and 2R instead of 1R and 4R. Okay. And don't forget about that GCF thing. That could save you a lot of guesses. So make sure you're looking. Is there a GCF here or here? Because if so, I'm not even going to bother anymore. Okay. All right. So there's that. So we have one for you guys to try. Let's see how you do. Wrestle with it. Watch out for those GCS. It could save you a lot of guesses. If you see anything in common on those two, then it won't work. You know that's not working. Now, so that's going to work. 24 and 5 makes 7. So that means that it worked. Now, what I would say is you could try switching these. That's not going to work. Because if you do that, you're going to 4 infinite, and you can't have GCF with 6. So let's try something else. I'll give you a little help in the right direction here. I'll put the answers up for you guys. That way, if you finished and you thought you had it right, you can check to make sure you're right. If not, you can kind of use that to kind of guide you a little bit to get into the solution. You can work with your box there a little bit. So just as a pointer, guys, I'm going to look at your homework and see how you guys do with these. If it looks like we need more practice, maybe I'll make a little change. We'll practice a little more tomorrow. But if it looks like you guys got it, we're moving on. But if you are in the camp of not getting these things, this is a thing where you want to set aside some time, go get some tutoring, because factoring is a huge concept, a very important concept, especially these ones. Just because they're hard, but they come up all the time. Very useful for a lot of things in math. So if you don't get it, highly encourage some tutoring. But we might spend more time on it tomorrow. We'll see. I'll look at your homework and come to a decision. We will see you guys mañana. How'd I do it?